Hello and welcome to the CODESYS webinar about our new product, CODESYS Profiler, which is available since mid of last month. So I will guide you through the webinar. My name is Michael Schwartz and I'm working for the product marketing at 3S. So just a few general information up front. So you can get most of the information I provide you out of the online help of the CODESYS development system when the add-on of the CODESYS Profiler is installed. In addition, you can find some basic information about products on our CODESYS website. Some information on older webinars can be found on the YouTube channel of CODESYS, and this webinar will be provided on YouTube somewhere in the near future. If you want to get the presentation as a PDF, just send an email to the email address webinar@codesys.com. Going to the webinar itself. So it's structured into 4 sections. First is to get some introduction about the motivation, then followed by some basics to the methodical software development. Then I show you the integration of the CODESYS Profiler into the CODESYS development system and some typical use cases. And finally, there's a summary, of course, summarizing what we have presented today. Starting with the motivation. So why do we use the different tooling here? So first of all, it's the general approach of the methodological support, the automation of some functionalities. When we start here on the left-hand side with the architecture following a kind of V model, then it's that the first step is to provide the architecture in CODESYS UML so that you have here a better overview on what you want to program. Then when you want to make more details in the coding, you can use the CODESYS static analysis to see which quality your coding has reached. When the first lines of code are available, you can use the CODESYS SVN to make a release management with the Apache Subversion. Then I step over this performance item, followed by the functionalities, so you can validate whatever you have programmed in your application with the CODESYS Test Manager. And this webinar is then when we talk about performance and using CODESYS Profiler as a runtime analysis and system for development optimization. Have a look on the profiling from two sides. Is the first one to use the information which you get out of the profiler to optimize the application for fixed controller performance. When you want to play a little bit with the application code to get on the boundaries of the controller performance. The second one is that you can estimate which kind of controller performance you need for known applications. So, for example, you have already an application out in the field and you have a hardware redesign where you want to see whether you can use cheaper hardware. You can see out of the performance measurements whether there's the option to buy a hardware with reduced performance. The other thing is that you can use the information for testing purposes. So by using the automation, it's a reduction of the analysis time, so you can do it more often and fully automated. And by this, we assume that you need fewer regressions because you can do it on an early stage in development so that you don't get the information whether the application fits on the controller at the end of the development cycle, but you can measure it whenever you want, best case on a daily basis. So all these concepts are known by the IT projects or embedded C, C# development systems, for example, used in the automotive industry. And with the CODESYS control runtime system in combination with the CODESYS development system and the profiler, you can use this methodology now also in IEC 61131 systems. Let's see what it will bring to you. So the basis of this methodological software development is that the tooling or the methodology can be used in any software development model. So it's not dependent whether you use a V model or whether you develop in Scrum. And even better, for safety products which are following the IEC 61508 with the SIL 2 level, the usage of such profiling is even recommended or highly recommended for SIL 3. So you should think about using the profiler to automate here these activities. By the automation, the methodological support should and could be used more often during the regular software development without spending more effort. And when you see at the arrow on the bottom, we would place the profiling at the end of the coding phase, just before you start the official debugging. With all the other tools of the CODESYS Professional Developer Edition, Profiler enables you to analyze and optimize the runtimes by merging some minor binary code snippets or parts to your application code. And because it's done automatically, it can be done by anybody who is able to work with the CODESYS development system. So it must be included as an add-on, and then it can be used by software developers and by engineers, service technicians, so everybody who's able to work with CODESYS. So no special programming knowledge needs to be there, and programming knowledge would be mandatory when you do it manually, because you need to know where all the entry and exit points would be in the code to add the measurement points manually. So that's what the CODESYS development system can do automatically using the CODESYS Profiler. Also, when the real hardware is not available on an early development phase, you can use the runtime measurement with the CODESYS soft PLC, and then finally, when you transfer then the development, the software development from the pure software to an integration step where you combine then the software with the hardware, you can also measure the runtime behavior directly on your real hardware. So that's step 2, and now we start with the integration into the CODESYS development system. So without a CODESYS Profiler, you already have some information in the CODESYS development system about timing. So it's part of the task configuration information. And with the CODESYS Profiler, you get some more detailed information on these tasks that are already shown there. As I said before, you get this information by installing the CODESYS Profiler from the CODESYS store. It's then part of the CODESYS development system managed by the CODESYS package manager. So the integration into the CODESYS via the package manager brings you the update functionality as well as the license monitoring. With the update functionality, you know all the time whether there's a new version available in the CODESYS store, because the package manager takes care about getting this information for you. And you see also in the license information whether the CODESYS security key is available at the moment on your PC, or whether the CODESYS Profiler is just running on a demo mode, or whether it's running on a demo mode or on a full version mode. When the CODESYS Profiler is up and running, you see in the CODESYS development system 2 new items in the menu bar. One item is to make all the settings to include the measurement in your application project, and the second icon is to read the measurements from the PLC and to display it on the CODESYS development system level. The typical use cases, I mentioned some of them already before. It's to use the CODESYS Profiler during test, so to get the information as early as possible to identify some possible savings on existing or released hardware, to analyze the optimization potential of updates or upgrades for existing software applications. So you can decide whether an upgrade in the field is possible with the existing hardware. You have the option to verify the performance and task requirements of the application as a verification task. You can support the debugging and error diagnostic of the application even in the field, so after release of a specific application. So let's switch to the live demo. Everything what I've explained you so far is more or less already done here. So you see the two icons on the top for the CODESYS Profiler. When I go to the CODESYS Package Manager, you will see that the profiler is already available at the moment, working with the version 1001. And so when I want to use now the profiler on this existing example project, which is called Mahjong, so it's a game here, which I've also put out of the CODESYS store, you can first start with the settings. So the settings will bring you, first of all, to switch to enable or disable the profiling for the next login procedure. You can see which task shall be monitored. So in this case, it's just one task, but if there would be more than one task in the task configurator, you could choose in this drop-down the other tasks as well. Then you can select the timing format, so how the time is displayed in this case, followed by the buffer size. So the buffer size has to be defined because the measurement results have to be stored on the PLC. So when the buffer size is too small, the profiler will not run. If the buffer size is too big, you even might get out of memory because it's not enough memory there. So you have to take care that you enter here the right buffer size. Then the recording mode, you have two options: to measure the next cycle continuously or to store only the maximum cycle time. So when you have in the internal memory stored a certain time, the next higher time will override the existing value here. So that's what I choose at the moment because for demonstration it's the best. And finally, the condition. So you can combine the profiling with a variable. So when this variable is true, then the profiling starts, and it can be ended as well. So you can measure an amount of 1,000 cycles, and after this, get the maximum number here back as a result. Then the critical limits. The critical limits are only for display reasons, so that you get the critical path here displayed in the results when you load the measurements feature for easy analysis of the results. And getting back to the records, so I enable now the profiling so that I can show you the example, and then we load this Mahjong application to the soft PLC, which is already running here. So we download now the merged application and profiling code to the PLC. We start the PLC so that the application is running. And now first let me show you the task configuration here. So in the task configuration in the monitor, so that's more or less the profiler light. So you see here information about the average cycle time, max cycle time, cycle count. So here you can get the general information about the application. For the more detailed application, we can press now here the profiler results. Now the measurement points are collected and the result is displayed in a new result window. So in the overview, you can see which device was used, so it's a soft PLC at the moment. You can see which application was measured. You can see the compiled version and the number of instrumented PUUs. So that's more or less the general project information. In addition, you can see which task is running with this application. You see which cycle was the maximum cycle. And when you compare now, we are on a cycle 1000 and somewhat. And in cycle number 7, there was already the maximum duration measured. So with 82 microseconds, 0.082 milliseconds. And you see also the calculation here that the milliseconds is measured in ticks and just displayed in milliseconds. And you see also that the recording conditions, so that we don't have any recording conditions. So we started immediately our recording. So that's more or less the idle mode of the application. So you can get the information about the idle mode again and again and again and again, but always with some minor deviations here. So the first result was 82 microseconds, and now it's 79 microseconds in cycle 902, and when I press a third time, there will be a statistic on the cycle time. So it's now 80 microseconds, or in the overview, 82 microseconds. So that's statistically, it's not because the profiling is bad, that's because the times vary. So we have then, beside the overview, 3 kind of available structures. We have the call tree available. So that's the view from the main task into the different programs and functions. And here you see also these red indicators. So that are the critical limits which we have set before. So you see here, this is the critical path, and the most time-consuming function was selectable tile. So that uses close to 50% of the mandatory cycle time or task time. You see also that this function was called 144 times. When I want to see more details on each call, you can get also all the 144 measurements. It's low, but on average, it's 40 microseconds. Also pressing the right mouse button, you get some properties on this function. Also here, at the moment, it's not that much information, but you see you can get the average time, minimum and maximum time, as well as the standard deviation. Now let's challenge CODESYS. So the other views I will show you with some more meaningful information. So challenge CODESYS means that in the background some calculations will be done, and CODESYS calculates how many tiles will be left when CODESYS would play the game. So in this case 52, and when I get now the profiling results from this calculation, you will see that these are different to the idle mode results. So in the overview, you see now instead of 80 microseconds, duration is now 5.767 milliseconds. So that's now higher than before. And in the call tree, you see why. Because there are, first of all, used much more functions and programs than before. So that's when we open here the complete tree. And you see also that now the critical path is still the selectable tile, but now with 74,169 calls. So I could now get the detailed times as well, but that would take some time here. So I go to the properties and see also here the information. And when I want to know more about the details on this function, I can open the PRU directly out of these measurements. So when I want to maybe optimize something here in the PRU, I'm directly there. So because the average time is more or less 0, it's maybe not the main information which has to be, or not the main function which has to be optimized. But to get the function with the most potential, you can look here in the list and selecting here the average times, and you see the CODESYS play function needs the most time in average. So you can also go here directly to the PRU and do some optimization on this function. When you don't want to do this now because it's still in development, then you can export or copy the table to compare it later on with the final version of this function or with this PRU. So the export can be done on comma-separated file level, and copy is just a copy-paste so that you can use it then in Excel, for example. When you select your different functions, you see on the bottom which functions are called by this PRU, and in this case, this function calls 2 other functions, so you can then go to them and see whether you can optimize here in the called function something which influences your result. Beside the list, we have a different view. It's the opposite from the call tree. It's called backtrace because you look now from the function into the direction of the main tasks. So the last entry here will be always the main task because in this case all the functions are called by the main task because this is our only task which is running here. So you can have 2 views here, either top down or bottom up. So that's more or less everything what you can do with the CODESYS Profiler. So let's go back to our presentation. As you see, with these 2 settings, you get different views which you can use for analyzing your application. And now we are already in the summary part. As we presented before, the profiler is integrated into the CODESYS development system, and with an enabled profiler, you can make as many measurements as you want to have during the application development here. So even you can log out, make some changes, log in, make a new measurement, compare it directly with the measurement before. So that's everything is possible here in this scenario. Then you have the option to activate the runtime measurements, and much more important is that you have the option to deactivate the measurement, because by deactivation, automatically added code is no longer added. So when you finalize your development, you deactivate the profiling, and optimized code is loaded to your PLC. So you have no empty code which is running on your PLC. And you have the 2 recording options: continuous storage of the measurement results and storage of the maximum execution time. So my advice would be to use the maximum execution time, because during development that's in combination with critical application. So that's then also the critical time. So don't use the application in kind of idle mode, because then you don't get the maximum execution time, then you will get the minimum execution time, and this does not help for optimization. Then you can make a free selection of the display, whether you want to display the results in ticks, milliseconds, or microseconds. You have the option to navigate directly from the measurement result to the affected PRU, so that's for fast optimization. And then you have the option to make different displays here. So the overview display is more or less for documentation, so you can make a screen copy and paste it into a validation or verification document. You can use the backtrace or call tree to have a look on the application from top down or bottom up, and you can use the list to get all the information for your application in one table. So in this table can be stored for trend analysis or for further usage here. So we are now more or less at the end of the webinar, so you can get the CODESYS Profiler directly in the CODESYS store. Demo version, which is available there, is time and application size limited. You can get, of course, higher volumes than just downloading one CODESYS Profiler from the store. So therefore, please contact the sales department on the options here. The minimum requirements to run the CODESYS Profiler is that you have a CODESYS development system version 3.5.0.2, so that's an error here in the presentation. You need the CODESYS security key to run the license on it, and you need to have a CODESYS control runtime on your PLC, which supports the sysget ticket counter, so that's for fast profiling results. And if this sysget ticket counter is not running, then the profiling results will have a bigger error. So at the moment, the deviation from the real runtime is approximately 20 to 30% when you run it with the sysget ticket counter. When you have to use an external function, then it's even higher. Then you have a deviation of approximately 30 to 40%. But you can still use the results because it's just statistically, so you can switch off the profiler, make the measurement of the task and the application, the complete application time without the profiler, switch on the profiler and see what's the factor which you have to add on your results. In addition, as I said before, we have some more tools for methodical support for systematic development that are all the tools of the CODESYS Professional Developer Edition. As I mentioned before, UML, SVN, static analysis, as well as a test manager.